This video is going to deal with tuning. In this particular case, it's the same pipe that you saw in the other video, except it's 1 inch or 2.5 centimeters shorter. This means that the system will be tuned for a higher RPM. However, the engine may or may not be able to produce the power to turn the extra RPM, which will cause the engine to fall out of tune and actually run slower. Now, in the case of this video, I'm going to run 2 different datum points, and there's going to be some fumbling around in the middle, so forgive me for that. But right now, we're going to run it at the other test, by the way, was 17 inches. That's 2.54 centimeters per inch, measured from the center of the glow plug to the end of the pipe. Now, this particular one is 16 inches, so it's about an inch shorter, 2.5 centimeters. So if the engine can produce the power, it may actually turn faster than the 16,500 that we got last time. So we're kind of right in the middle at the peak of that curve. So let's see what happens. What happened that time was that when I first started up the engine, it ran briefly at 16,000. Now that gets into the temperature, the speed of sound at temperature, because when the muffler was cold, the engine was able to tune slightly and turn 16,000. So as the muffler heated up and the gases inside the muffler got hotter, the acoustical length of the muffler got short enough that the engine could no longer tune itself. Maximum RPM then was 14,000. So you do need to remember when you're running tests that you make sure the engine has gotten hot enough so that everything stabilizes and you get consistent data. So after it did stabilize 14,000, that's it. That means the pipe is too short. So what I'm going to do now is I'm going to take this assembly apart and put in a pipe length of 18 inches, and let's see what happens. So you can observe how this little system works with the screws, assuming I can find my screwdriver to, oh, fell on the floor. Be careful when you touch these pipes, they can be hot, so I'm going to have to make sure I don't burn myself when I do this transition. It's not exactly the same pipe as before, but it's the same type. This is just a test pipe of mine that's been welded together. All the same data though, no problem. So let's go back to the original pipe. This is the original pipe and the original header. So for convenience sake, we can use the same setup, and you'll notice with your tuning pipes that they sort of slip inside of each other, and you can make an adjustment like a trombone. And if you sort of hold everything together, you can do this quickly and easily. So I'm going to set it up and I'm going to measure it. So we're going for 18 inches. Right now we're 18 1/4. I'm going to shorten it a little bit. And since you're going to be plotting data, it doesn't really matter that you have these linked exactly right, because you plot the curve and you see where that peak occurs. Then you look at the data and you say, well, gee, I think the optimum length for this is, somewhere in between. So you go back and you run the data again. I'm using what we call here drywall screws. They go in and out of the wood very easy, and it allows you just to adjust anything you want. People have made much fancier. Sounds like somebody's talking back there. Okay, so I'm hooking back up again, and I'm also about out of fuel, so I'm going to put some fuel in the fuel tank. This is just a standard crank pump. If you're using a bubbleless tank, you may need a different kind of system, but for this tank, everything's all right. Okay, tank's all filled up. So now it's exactly 1 inch longer, 2.5 centimeters, and if I didn't overheat it the last time, it did get hot. The glow plug will still be good. Sometimes you can hand start. Recommend that you hand start like I did. If you watch closely, you saw that I actually slapped the prop backwards. I did not try to turn it all the way through. It's just a quick thing like that. Unless you're very skilled, don't do it. So what did we get? With an 18-inch muffler, we got slightly more RPM than we did with a 17-inch muffler. But you can, for practical purposes, you probably can call it the same. So if you plotted the curve, you'd see that there's a flat spot there, and perhaps you need to test again, maybe another inch longer. So now you have 4 data points, you have a nice curve, and you have an optimum length for the muffler. Now, as far as optimum length, I like to be conservative. And conservative means run it a little bit longer. Maybe you know, maybe 1 centimeter longer than what you think is the peak of the curve. So now this is a relatively small prop. Some of the other props you have are going to have peaks that are maybe 14,000. So the pipe is going to be longer. So in any given case, make sure you start very long and shorten it maybe 2-3 centimeters at a time as you take your data. You can't just jump right in the middle and use the same data for any particular prop. That's about it for tuning. You will get good data if you do what I say. Now you may also notice that I didn't touch this needle valve after the original setup. When you go to a larger propeller, you may find that you have to open this slightly because you're not generating as much pressure in the pipe at a lower RPM. So for any particular prop, you may need to readjust this that one time before you run your data.